Hello all, my name is AC and today I will be teaching you math. Today's section is 11.3, the area of a trapezoid. Let's get started. Now, I don't have access to my whiteboard today, so I'll just be using it online. Let me know which format you guys like better. So, first off, this is some information that we're going to be using is to find the area of a trapezoid, which is the average of the bases, or base 1 plus base 2 over 2 times the height. So in this case, it'd be 5 plus 9 over 2. So 14 over 2, which is 7, times 3, which is 21. So the area of this trapezoid would be 21 centimeters squared. Alright, problem number 1. The bases of a trapezoid are 8 and 22, and the trapezoid's area is 135, and we have to find the height. So this is something we can use to build off of later on, but right now, we just need to be able to understand this. So we can just plug everything into the formula. So 8 plus 22 over 2 times the height is equal to 135. So what we're doing here is we already know most of the information we need. All we need to do is find the height. So we plug into the equation and we can solve it. So 22 plus 8 is 30 over 2 equals 135. H times 15 is equal to 135. H is equal to 9. And yeah, that's the answer. This is a super simple problem, but I think it's a good prerequisite for the later problems that we have to be doing. This kind of problem solving we need to have. Alright, once again, this is a problem that we can use to build off of later on. This is kind of something we need to understand as well, which is to find the median, or this right here. So a straight wire stretches between the tops of two poles whose heights are 30 and 14 feet. These two right here. Let me label this M for median. Find the height of the pole that is to be placed halfway between the original poles to support the wire. Assume the poles are perpendicular to the ground. So yeah, the hint right here, do you see a trapezoid and its median? So right now you might not see a trapezoid. You're thinking these two bases are not parallel. However, even though if you can't see this, you're like, the bases aren't parallel, this can't be a trapezoid, all I have to do is flip the shape. We see the legs here are parallel, which means if we just flip the shape into something like this, we now have a shape and we can find the median here. And yeah, it's halfway between the original poles to support the wire. So we just need to find this. And in order to find the median, we just take the average of the two bases, which is 30 plus 14 over 2, or 44 over 2, which is 22. So this is our answer. The pole is 22 units long. Alright, next problem here. The area of a triangle PQS is 25. The median of the trapezoid PQRS is 14, and the base RS measures 18. We need to find the length of base PQ right here. We need to find the height to base PQ of PQS, which is this right here, and the height of trapezoid PQRS, which is once again this right here. And then we also need to find the area. So let's start with the length of base PQ. So we know the median of the trapezoid PQRS is 14, and we know the equation base 1 plus base 2 over 2 is equal to the median, and we already know what one of the bases is, and we already know what the median is. We already know what one of the bases is, and we already know what the median is. Therefore, we can solve this equation, as now there's only one variable that we need to solve for. So if one base is 18, we can do something like this. Over 2 is equal to the median, which is 14. And we can solve for this. I'm just going to switch the variable to b. 18 plus b is equal to 14 times 2, which is 28. b is equal to 20. Okay, so we know this is 10 now, and the height to base PQ of triangle PQS, which is this shape right here. We're going to find the height to base PQ of the triangle PQS, and we know the triangle the area of the triangle is 25. So once again, we can use another formula, which is base times height over 2, which is the area of a triangle. And we already know what the base is, which is 10, and we already know what the area is, which is 25. 10h over 2 is equal to 25. Once again, all I'm doing is just substituting variables for the numbers we already know. So once again, solving the equation, 10h is equal to 25 times 2, multiplying both sides by 2, the height is 5. So we know the height right here, this right here is 5. Now we need to find the height of trapezoid PQRS. And as you can see, they're the same thing. So this is also 5. Now we need to find the area of trapezoid PQRS. And we have all the information we need. We have one of the bases, two of the bases right here, and we also have the height. All right, so now we have all the valid information we need to find the trapezoid area. So we know the equation. We find the average of the bases and we multiply it by the height. 10 plus 18 over 2 times the height, which is 5. Average of the bases is 28 over 2, or 14. So it's 14 times 5, which is 50 plus 2, which is 20. So 50 plus 20, which is 70. So the area of the trapezoid is 70 units squared. And these are all the answers. Okay, next question. Find the area of the figure shown, which was formed by cutting two identical isosceles trapezoids out of a square. I enlarged the figures so I can actually work on it. So we know they're identical, so we already know that this is 7. They're isosceles, so this has to be 5, this has to be 5, and this has to be 5. We also know this is 13. After all, it is a square, so we know all the sides are also 13. This already gives us a lot of information we can work off of. Okay, so first thing I'm going to do here is, if this base is 7, we know it's in the middle of this base 13, which means both of these sides are going to be equivalent. So 13 minus 7 is 6. So we know both of these sides have to be equal, so it's 6 divided by 2, which is 3. So we know each of these sides is 3. If this side is 3, and this side is 5, and this is a right angle, this creates a 3, 4, 5 special right triangle. So now we know that the height is 4. We just need to find the area of the bigger rectangle, which is 13 times 13, and we need to subtract it by the area of the two trapezoids. So first, let's find the area of one trapezoid. We take the average of the bases, 20 over 2, 10, multiplied by the height, 40, or 4, and this gives us 40. So now all we need to do is subtract this by two trapezoids, in this case 40 times 2, or 80, and this will give us our answer. 13 times 13 is 169, minus 80 is 89. That's our answer. 89 units squared. Alright, next problem, number 12. The perimeter of a trapezoid is 35. The non-parallel sides are 7 and 8. We need to find the trapezoid's area if its height is 5. So I already have the trapezoid drawn here. Size 5, the height is 5, one side is 7, and the other side is 8. So we know the perimeter is 35. So what we can do is similar to something we did in 11.2. We can label the sides using a single variable. So let's set this side to x. That means this side will have to be 35 minus 7 minus 8 minus x. This side has to be the perimeter minus every other side, which means this side is 35 minus 7 minus 8, which is 7 plus 8, or 15, minus 15 minus x. This can be simplified again. 35 minus 15 is 20 minus x. So we know this side is 20 minus x. And once again, it doesn't matter which side you flip them, as it is a variable. So if you had this side labeled 20 minus x, you just had to make sure this side was labeled x. So now we need to find the area. And right now, there's no real way of solving for these two variables right here, or these two x's. So instead, we can plug them into an equation. After all, these are the same variable. So once again, we need to find the area. So we use the area formula. 20 minus x plus x. Now this is redundant, and you'll see later why. And we have to take the average of this, and we multiply it by 5. This is the area. So we imagine this is 5 times 5 over 1 times 20 minus x plus x over 2. So we need to multiply 5 into everything here, like this. So it's 100 minus 5x plus 5x over 1 times 2, which is 2. Okay, now we can simplify this further. Minus 5x plus 5x, no matter what x is, this is going to simplify it into 0. So we can just take it out of the equation. Now this we can solve. 100 over 2 is 50, which means the area is 50 units squared. And that is the answer. Okay, when an isosceles triangle is folded so that its vertex is on the midpoint of the base, a trapezoid with an area of 12 square units is formed. Find the area of the original triangle. Okay, now we're on some problems that require some true thinking to solve. Let me construct 2 shapes here. Oh, that's not an isosceles triangle. Okay, that's close enough. And then, okay. So I just went ahead and just drew the 2 images, and we know the trapezoid has an area of 12 square units. And we need to find the area of the original triangle. So we know that this top right here, we know that this point right here has come and has folded down into the midpoint, like right here or something or whatever. And it creates this trapezoid here, and I kind of drew like this right here. What do we know about this trapezoid? Well, first off, we know that the segment split is like this. What else do we know? It's an isosceles trapezoid, so this is congruent to this. These 2 sides are congruent, and these 2 sides are congruent. We also know that these 2 angles are congruent, and we know this angle and this angle is congruent to this angle as well. So we know all of these angles are congruent. What else do we know? Well, there are 2 ways of approaching this problem. We know it's folded so that the vertex is on the midpoint of the base. So these 2 sides have to be congruent to each other as well, as you can see here. But if these 2 are congruent, and this triangle is here, and it gets folded down, then that means this side right here and this side right here will have to be congruent. We can assume this, that all of these sides here are congruent. And now we know that this triangle right here, we know that triangle 1 is congruent to triangle 3 through side, side, side. However, we're not so sure about triangle 2 yet. However, because we know that the bases are parallel, we know that this angle, because of alternate interior angles, is congruent to this angle. And we know, once again, because of alternate interior angles, this angle is congruent to this angle. So that means that all 3 of these triangles are congruent. And once again, if this side is parallel and this side is parallel, we know that this is parallel to this as well. So we know triangle 4 is also an isosceles triangle, and because of here, we know that they're congruent to these sides as well. So we know that all 3 of these triangles are congruent, or all 4 of these triangles are congruent. And if the trapezoid has an area of 12 square units, all we need to do is do 12 over 3, which gives us 4. So we know the area of each triangle is 4. And if there are 4 triangles, it's 4 times 4, which is 16. Which means the area of this figure right here is 16 units squared. And that is the answer. Okay, next problem. The sides of a trapezoid are in the ratio 2 to 5 to 8 to 5. The trapezoid's area is 245, and we need to find the height and the perimeter of the trapezoid. So I went ahead and I constructed the figure. And once again, I used x as a scale factor because we know all the sides are in the same ratio, which means when we scale one side, all other sides have to be scaled. We can scale it by x. And if the trapezoid's area is 245, we have one variable for the base and another for the height. So right now, we can just create an equation using the formula. So we find the average of the bases, 8x plus 2x over 2, 10x over 2, 5x, and we multiply it by the height, 5hx. which is equal to the area, 245. We can simplify this further. Hx is equal to 5 times 40, 49. This much information we know. Now, what other information can we find out from this trapezoid? Well, it's an isosceles trapezoid, which means this side right here, separate from the base, is going to be equivalent to this side right here, separated from the base. Now, this is pretty useful. So, 2x minus 8x is 6x, which means that this side right here and this side right here have to be equal and equal to 6x. 6x over 2 is equal to 3x, which means this side right here and this side right here are both 3x. Now, once again, if you notice here, if you scratch out the x's, you see that this side is 3, this side is something, and this side is 5. This is a special right triangle, once again, a 3, 4, 5. However, we both need to scale, the height by x, so this side will be 4x. Now we know the height, and we can plug it in to our equation right here that we have created. So 4x times x is equal to 49. 4x squared is equal to 49. Now, this number right here and this number right here are both squares. And so is this number right here and this number right here and this number right here. All of these are squares. What we can do is square root both sides. Now, when we square root something like this, we need to square root both of the numbers. So it's the square root of 2 times the square root of x squared is equal to the square root of 49. Or this is the square root of 4. So square root of 4 is 2 times the square root of x squared, and the square root of any square number is just a number. So 2 times x is equal to the square root of 49, which is 7. X is equal to 2x is equal to 7. X is equal to 7 over 2. So now we know what x is. Now we can solve for the perimeter and the height of the shape, because they are all in the same variable, which we now have solved right here. So let's first solve for the height, which is easier. So we know 4x is equal to the height. Now we know what x is. 4 over 1 times 7 over 2 is equal to the height. 28, not 88. 28 over 2 is equal to the height. The height is 14. And for the perimeter, we can just add up each side, which is how you find the perimeter. So 8x plus 2x, which is 10x, and 5x plus 5x, which is 10x. 10x plus 10x is 20x, which will give us the perimeter. 20 over 1 times 7 over 2 equals the perimeter. 140 over 2 equals the perimeter. And 142 is 70, so the perimeter is 70, and the height is 14. Units and units. This is our answer. All right, our last two problems here. Find the area of the trapezoid. Now I'm going to reconstruct this a little bigger. All right, I can't draw at all, so I just reconstructed the figure. Now, we know this side is 5 root 3 and this side is 12. It's a little blurry, but we also know one angle here is 30 degrees. So now, whatever we need to do before each trapezoid problem is try to find a right triangle. And then special if we can. I can't spell. Okay. And then I'll give you some time to go and try to find a special right triangle if you can. Okay, so what I do first is I'd create a 30, 60, 90 triangle right here. 30 plus 90 is 120, 180 minus 120 is 60, so we know this is 60. The side opposite of 30 is always half of the hypotenuse. So we know this side is 6, which means this side would be 6 root 3. And then we can create another one. If we know this side is 90, we know this side must be 30. And because we know this side is already 6, because both of these are the heights of the trapezoid, we know that this side will have to be x, which means this side right here will have to be x root 3. And this side is, and because we already know what it is, we can create this equation here. X root 3 is equal to 6. We can solve it. X is equal to 6 over root 3. X is equal to 6 root 3 over 3. And if you don't know this step right here, I highly recommend watching a video on how to rationalize denominators. And we can simplify this even further, because 6 divided by 3 is 2. So x is 2 root 3. So we know this side right here is 2 root 3. And because this side right here is 5 root 3, we know this side has to be 3 root 3. And if this side is 3 root 3, we know this has to be 3 root 3. Now we can finally solve for the area of the trapezoid. We have both of the bases and we have the height. Let's do it. We know one base is 5 root 3, and the other base is 3 root 3 plus 6 root 3, or 9 root 3. You find the average of these, multiply by the height, 6. 9 plus 5 is 14 root 3 over 2, 7 root 3. 14 over 2 is 7. Multiplies by 6 is 42 root 3 units squared. That is the answer, and that is the area of the trapezoid. Alright, our last problem here, the area of this trapezoid. We know this angle right here is 30, and that should already tell you something. And this side is 12. Once again, try to find as many right triangles as you can. Alright, hopefully you found a few. So if you didn't notice right here, this is already a right triangle, and you can solve for this angle right here in a multitude of ways. First off, you know this triangle is isosceles, which means this angle is 30. What you also know is that the bases are parallel in a trapezoid, which means because of alternate interiors, this is also 30. Now, you know that this is 60 as well. And look, it creates a 30, 60, 90. So, side opposite to 30 is always half the hypotenuse. So this is 60, which means this side right here will be 6 root 3. This side right here. Okay, so we have one base, and it's isosceles, so it's also this base. And we know that this side is right here is congruent, this right here is congruent, and this right here is congruent. So we know this side is 6 as well. Now, we have almost all the information we need to find the area. We have both of the bases, but now we just need the height. Now, try to find a way to solve the height using a right triangle. Okay, so what I would do here is, I already know this angle right here is 60. So I'm going to create another right triangle. Now, you can also do it on this side right here, because 30 plus 30 is 60, but it's easier to do it on the left side. This is 60, this is 90, we know this must be 30. And we know the hypotenuse is 6. Side opposite 30 is always half the hypotenuse, which means this side is 3. What else do we know? If this is 3 and this is 6, we know this side has to be 3 root 3, or x root 3, which is 3 root 3. So now we can solve for the area. We have both of the bases and we have the height. Alright, so now we have the height, we have both of the bases here. Now we can solve for the trapezoid. We find the average of the bases. 6, divide both of these by 2, 6 plus 3, 9. And we have our height here, which is 3 root 3. Multiply this by our height, 27 root 3. And that is our answer. Units squared. Once again, thank you guys for listening. Thank you guys for following along. Let me know any questions, comments, or concerns about my videos, and I'll see you next time.